Okay, in this session, we're going to talk about correlation and how to calculate correlation in R. There's a lot of complicated math underlying the calculation of correlation, but R will take care of all of that for us automatically. That makes it even more important to understand what correlation means. Correlation at its most basic is just whether two things change in the same direction, in opposite directions, or whether there's no relationship between the two. So what we want to know with correlation is if we increase one thing, will the other thing increase as well? So looking at my screen now, you can see that this graph displays a few different correlations. Correlation can run from +1 down to -1. A perfect correlation of 1 means that if one thing changes, the other will change in the same exact amount every single time. Generally, we won't find perfect correlations in the world, either positive or negative. And so we're generally looking at this sort of range of correlations between 0.9 and -9. A really strong correlation of 0.9 means that there's a really consistent relationship between the two. A correlation of 0 right in the middle means that there's no correlation. If one thing changes, we have no expectation about how the other will change at the same time. And so a correlation above 0.3 is considered moderate, between 0.3 and 0.6. 0.3 and 0.6 in absolute units, so -0.3 and -0.6 is considered moderately strong. Anything above 0.6, so either 0.6 to 1 or -0.6 to -1, those are both considered really strong correlations. And so when you're starting a project, if you're looking at the relationship between two things, looking at new business creation and gentrification, or the impacts of flooding and neighborhood change, what you want to start with is just looking at the correlation. Do these two things go together consistently? If there's no correlation, generally whatever statistical test you run later won't show a relationship. If you sort of back up to the most basic test of the correlation, you'll see the relationship there, and that's where you can build out. So as I said, calculating correlation in R can be really simple. There's one trick or one tricky aspect that we'll go over later. But at the most basic, it's just one word and two ways of calculating it. So I'm reading in this data set for Swiss again that we've used in past exercises. And there's two ways to calculate correlation. We can either do it for two variables in particular, or we can do it for an entire data set. So this first one here, after we read in the data Swiss, is calculating the correlation between the variable Catholic and the variable infant mortality. And the correlation is 0.17, which, as we said earlier, is generally sort of a weak correlation. That doesn't mean that there's a very strong relationship between the percentage of Catholics in Switzerland and the infant mortality at the province rate. The other way of looking at correlation is to do it for an entire data set at the same time. And so if instead of entering the specific columns that we're interested in, we just put in the entire data set Swiss, it'll actually calculate the correlation for all of the variables individually at the same time. And so we can see this same figure of 0.175 for infant mortality and Catholic down here. We look at infant mortality and Catholic, it shows up. And so looking at a correlation matrix, what you're looking at is the columns and rows. So each variable is displayed on the columns, each variable is displayed on the row. And so each figure is the pair between the two. And so fertility correlates with fertility perfectly because it's the same thing. A higher fertility rate means a higher fertility rate. We can see the correlation between fertility and the percentage of people working in agriculture here. And we can also see it on the other side of the table here. This is the association between fertility and agriculture. This is agriculture and fertility. And so the matrix is mirroring itself on both sides of these ones. There's more advanced ways to drop either the top or bottom set, but they'll always match. Infant mortality and fertility here is easy to see. It's in the corners. And so these are going to go together. So you can either calculate all of the correlations at the same time, or you can do it one at a time.
Can I jump in here?
Yes.
So can you use the pander command on this like we did the other day, or is that just for other kinds of tables?
Yeah, that's a great question. So you absolutely can. So I need to read in pander, and I need to wrap my correlation in pander. And you again get a more attractive table with a little bit more spacing. So it wraps around here, which can make it a little bit more difficult to read. So that's one sort of consideration to take in, depending on how many variables you're using. But this gives it a little bit more space. It's rounding the figures also. This is going to the 7th digit. This is only to the 4th. And beyond sort of the 2nd or 3rd digit, you're not really learning a lot of more information about the correlation. So this is another thing that you can use Pander with to create a more visually appealing table. Yeah. So this was really easy with Swiss, and the same problem that we brought up yesterday. All of the variables in Swiss are numeric and continuous, so it's really easy to use in one command, like with the summary table. The correlation works the same. It can be used all at the same time. That can be more challenging in other situations, though. So I'm going to read in the package AER in this data set MA schools. And we can see again that some of these are not numeric. And so if I try to run the correlation table for this, I'm going to be told that it must be numeric. I cannot output a correlation matrix for all of the variables in MA schools. And so the second step then is the same as we went over in summary statistics. What we want to do is extract the variables that are of interest. So we could take all of the variables that are numeric if we wanted to. I'm taking 4 here. But I'm creating this second object, MA schools 2, with these variables. And then the second step in terms of doing a correlation matrix is that it's going to get angry if you have NA values in the data. Let me remove this line. So I get NAs for the variable salary because there are NAs in my original data. And so I need to remove all of the NAs because those values are non-numeric. R can't calculate a correlation for them. It needs each of the observations to be numeric. But once I remove those with NA omit, I can now get the correlations for all of the salary figures as well. And so I can make
another quick question here.
Yeah.
So you created this new object, MA schools 2, right? Which is just MA schools with the columns lunch, income, score for, and salary. And then you did it again where you omitted the NAs. So is this just basically creating a new object that is still named MA schools 2? Or do you have 2 different objects here that are named MA schools 2? Does that make sense?
Yeah, so with this step, if I'm reassigning it in this way, I'm essentially overwriting the initial MA schools 2 with this new one that doesn't have any NAs. And I could do this with my original.
So could you just continue to iterate in this fashion where you create a new object, MA schools 2, it's got the columns that you want. Now you want to get rid of the NAs. Could you add a 3rd step here where you modify this object further?
Yes.
Okay,
yeah,
cool.
so you can overwrite your sort of initial data as many times as you want. Let's say that I created this new object, which was just renaming MA schools and just dropping those columns out. And so I've got this, but I may decide, oh wait, what I really wanted was MA school, or for score 8. I didn't want the score 4, I wanted score 8. And now when I try to run that, I don't have that column anymore. Mm-hmm. And so now I would need to go back to the initial step, read in my original data, and then I can override it again. So this is why it's generally a good idea anytime you're changing your data set to give it a new name, so that if you're doing 7 steps along on the data set, you can actually go back and redo any aspect. If you figure out that the 2nd step was dropping too many observations, or you added in the wrong variable, you can just go back to that step instead of having to go back through all of them. And it helps you to identify where a problem is. But you absolutely can. So I still only have 1 MA schools at any time. You can only have 1 object with any given name.
Okay, thanks.
Just be overwriting it. All right, so that's all. So you can see here the Pander table for the correlations. that with 4 columns, it's pretty easy to read. It's a little bit easier. It's a little less scrunched. Sort of the preference is up to people if they want to use that or not. But that's all that I have on correlations. That's how easy it is to output correlation. And so a lot of the emphasis is on understanding what that number means. What does the number negative 0.55 mean? And that's covered in some detail in the textbook. But in terms of actually getting and outputting the correlations, there aren't a lot of steps that are necessary in R. So I'll turn it over to Jake for the exercise.
All right, sounds good. So we've lost a philosopher. It's just teacher and one philosopher to code for today anyway. Can you stop sharing your screen so that I can share mine?
Stop the share. Actually, speak of the devil.
Oh, there he is.
Donnie, you're late.
What's up, man?
You missed the whole lecture.
Oh, I thought, didn't we say we were doing this at 12:30?
We did not.
Oh.
But you'll get to watch Jake do the exercise.
Oh, I thought, sorry.
We're also recording. It's okay.
Okay.
I'm going to share my screen now, once Eric allows me to share my screen.
Okay.
Did you have to ask?
Says host disabled attendee screen sharing. Tut, tut, tut.
All participants there. Do it.
Got it. All right. All right. You can see my screen?
Yes.
Okay. So I've already loaded the
There's
AER
David.
package. But that would be
Oh no! Sorry. Ruined your video. Run away. Start over.
so I won't run this. But that is what I would do here, right? Install packages AER and then library.
Right.
So that's what that step would look like. Okay, now for loading the fatalities data set, is this just another library function?
No, so you load the package using library.
Okay. Oh, so this is going to be data, is that right?
Yeah. But you also, so where do you want to write that in a markdown document?
Oh, of course, I forgot. I need my, whatever this is called. I need my R thingy.
It's called a code chunk.
Boom. My code chunk, that's right. I don't know what this means.
Most of the warning messages don't mean anything.
Okay. I see fatalities here. So we're good to go then.
Yeah.
Oops, back to the exercise. All right, so now this is just like creating a new object, right? Fatalities 2. I gotta go back to my notes, I always forget. Right, square brackets. Oops, square brackets. Now I need, back to my notes here, parentheses, that's right. So income, employment, beer tax, and young drivers.
And then do you need that comma C thing?
Yeah, that's right. I don't know why I always forget that. Does that look right? That doesn't look right to me. Parentheses, forgot my, there we go. Something like that.
Nailed it. But you need your little R thing too.
Is that good? Oh, I don't know why I always forget. Okay, so I'm just gonna get rid of that. Insert my, is it R? Is that what I'm inserting here? Insert a new code chunk. Boom. That look good?
Looks perfect.
Okay, now I just parentheses.
What's the first step, Jake? What if you already forgotten twice?
Oh no, he quit. He gave up. Oh, there he is.
What happened?
You disappeared.
Sharing your
I
screen.
can't hear either of you.
You
You
should
went
keep that-
away.
You can't hear anything?
No.
Okay.
Can you guys hear me?
Yeah, I can hear you.
I don't know why I can't hear you.
Just finish. But you can't hear me. But can you share your screen? He can't. I don't know why I'm trying to talk to him. Wait. Okay.
So
Well,
I can try to load this thing up myself.
I think we'll just leave that for viewers at home.
Okay.
It was very close.
Okay.
Try to solve the puzzle for yourself.
Okay.
Until next time.
Sorry I was late and missed the entire thing, and mainly just was here for comic relief.
Quite the relief it was.